So this is the solution to the SHM Basics Graphs 7-mark question. It says, Figure 2 shows a mass suspended on a spring. The mass is pulled down by a distance a below the equilibrium position and then released at time t equal to 0. It undergoes simple harmonic motion. Taking upward displacement as being positive, draw graphs on figure 3 to show the variation of displacement, velocity and acceleration with time. Use the same time scale for each of the 3 graphs. So let's start with the displacement graph. That seems to be a sensible place to start. So it says upward is positive, by which it means displacement above the equilibrium position is positive. So it starts being pulled down. So at t equal to 0, the displacement is going to be minus a. So we're going to be down here somewhere. And we can choose where we're going to place a, somewhere on here, but then we're going to go from minus a to plus a as we go along. We don't have any measure of the period, so we can choose our own period for this graph. But it's going to start here, come up to 0. It's going to be a minus cos graph. So that's what we're going to draw. The velocity then, well, the velocity is going to be 0 because at t equal to 0, it's at the bottom, it's not moving. So t equal to 0, v equals 0, and then it moves up. If up is positive, then we have a sine graph. And then the acceleration, well, the acceleration is minus omega squared x. So this was a minus cos. This will be a cos graph. And the only thing that we need to think about here, apart from making sure that we use the same period for all of these, the only thing we need to concern ourselves with other than that is that we make sure that we know that there's an omega factor in here. So the graphs would look like this. So there's my displacement graph, and you can see displacement minus a t equal to 0, velocity 0 t equal to 0, acceleration is some positive maximum value there. And I have said a equals omega equals 1. That just makes life nice and simple. Final part of the question then. The spring stiffness is 32 newtons per meter. The spring is loaded with a mass of 0.45 kilograms. Calculate the frequency. Well, the period, as we know, is 2 pi root m over k. So if we stick in our numbers to that, we have 2 pi root 0.45 over 32. And of course, we don't want the period, we want the frequency. So we do 1 over that. And we get 1.34. And then we think, how many sig figs could we have? Well, we can only have 2. So it's 1.3 hertz to 2 sig figs.